So this week we're doing section 9.3. We're going to do the first part of section 9.3. We're going to take 2 weeks for this to give you plenty of time to get lots of practice and really feel like you know how to do this stuff. Also, no graphing here, we're solving. So we're kind of switching gears. This is all chapter 9 stuff. Sorry, chapter 8 was graphing, chapter 9 is solving quadratics. So we use solve by graphing in 9.2. Now we're going to solve by working backwards or using square roots. So that's our first learning target, is solving by working backwards using square roots. Second learning target is to simplify the square roots we get in that. So you'll see in your assignment, it's a 20 problem assignment, but more than half the problems I'm going to do here. So basically your assignment is some notes, some problems to work on your own, some notes, some problems to work on your own. So let's go ahead and jump in and get started. So what we want to do here, we're just going to start by solving the first problem, which is just x squared equals 49. And we're going to talk about what this means. So here, it means some number times itself squared equals 49. So we need to think, what number times itself is 49? Think about it. Okay, well, 7 times 7 is 49, right? So here, x could equal 7. Is there another number? If you multiply by itself, you get 49? Think about it. Well, that's a positive 7. A positive times a positive is a positive. What about a negative 7? What's a negative times a negative? X could also be negative 7. Because a negative times a negative is positive. So negative 7 times negative 7 is 49. So x could be negative 7. If we square that, we would get positive 49. X could also be positive 7. 7 times 7 is 49. The way we go about solving this, the way that I want to see it, is what you do is you do what's called a square root. So the square root is this symbol that kind of looks like that corner, northwest corner of Washington. So we do that on both sides, but because we're undoing a square that could have a positive or a negative answer, we do plus or minus the square root of 49. So once we square root 49, what we're doing there is we're saying what number times itself equals 49. We get x equals plus or minus 7. And then we write our two answers, positive 7 or negative 7. And that's our final answer. So while doing these problems, it's really, really handy to know at least 1 through 12 what those numbers are squared. So I'm just going to write them here. So we're going to have the number and then the number squared. So it could be like x and x squared. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. It'd be really good just to write these down on your paper so that you have them to refer to. So you don't have to keep hitting that square root button all the time. So here 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11 is 121, 12 times 12 is 144. So if you're squaring it, you get this number. If you are square rooting, so let's say if this is x, this would be the positive square root of x going this way. So if I have the square root of 144, that is 12. If I have the square root of 64, that's 8. Going this way in this table is square rooting. This way is squaring, this way is square rooting. If we're square rooting when we're solving an equation, we're going to go plus or minus. So let's jump to problem 2 here. So problem 2, this is problem 1. Problem 2 is 3x squared equals 48. So here, this problem's a little bit different. We've got this 3 that's multiplying by the x squared. Remember, when we're trying to solve by working backwards, just like we did with linear equations, so we try to get the x all by itself. So we just want like x squared equals something, and then we can undo the square by square rooting it. So that means I gotta get rid of that 3. And remember, anytime you got a number next to a variable, that's implied multiplication. It's saying, hey, it's 3 times x squared. So in order to get rid of that, we got to do the opposite. We're going to divide by 3 on both sides. So 3 divided by 3 cancels. We have x squared equals 48 divided by 3 is 16. So now it's just x squared on the left. We undo the square by square rooting. And because it's an equation, we need to remember this plus or minus. It's going to be a positive or negative of that square root. Because we could have a positive times a positive to get 16, or a negative times a negative to get 16. The square root of 16, we go to 16, that's 4, because 4 times 4 is 16. So here we get x equals plus or minus 4, and then the final answer is either x equals 4 or x equals negative 4. And I want to see both of these answers, please, written out like this. Not plus or minus 4, I want x equals 4 or x equals negative 4. Cool. So we have 4 more examples we're going to do together. We're going to kind of crank through these. They're just kind of different situations of what you might see. So for problems 3, 4, 5, and 6, what I want you to do, I want you to pause right now. I'm going to do them, but pause it, look at them, try to think about how you would go about these problems, even try a few, maybe, and then you can resume the video and go over the notes. So I'm going to give you a moment to pause it. Okay, hopefully you would pause it, work through them. We're back. Cool, let's look at problem 3. So problem 3, we got x squared minus 8, that's my dog, sorry, equals 17. Come here, Emma. Emma, hey, knock it off, knock it off, knock it off, Emma. One moment. Emma, come here, say hi to the Algebra 1 students. This is the little Parker. Say hello, Emma. Hello to the camera. Hello to the camera. Okay. There you go, you little grumbler. Alright, sorry about that. So x squared minus 8. Hey, knock it off. X squared minus 8 equals 17. Work from home. What we want to do here is we want to get the x squared all by itself. So what we got to do is we got to get rid of this minus 8 here. We're going to get rid of the minus 8 by doing the opposite. Plus 8 plus 8. That gives us x squared equals 17 plus 8, which is 25. So now we've got x squared equals number. That number is 25. We want to get the x all by itself, so we got to square root it to undo the squared part. Whenever we're square rooting an equation, we got to go plus or minus, because it could be a positive or a negative. We look here, what times what gives you 25? It's 5. 5 times 5 is 25. So we get x equals plus or minus 5. Write out our 2 answers, x equals 5, or x equals negative 5. Cool. All right, jump to the next problem. Here, problem 4, we have 3x squared plus 7 equals 19. So, once again, there's stuff happening to the x squared. So before we square root, we got to get just x squared equals number. So what we're going to try to do is we're going to try to get rid of this plus 7 and get rid of that multiply by 3. We're going to start with the last thing that affects the x squared. So we just read it. We're like 3 times x squared plus 7. The plus 7 is the last thing in the order of operations. That's the first thing we undo while solving. So we're going to go minus 7 minus 7. So here I have 3x squared equals 12. All right, look at it. Well, the x squared is still getting multiplied by 3. We got to get rid of that 3, so we go divide by 3. Because it's the opposite of multiply. So x squared equals 4. Once again, we just want x, not x squared. So we got to undo the square. We undo the square by square rooting. Anytime we square root while solving, we got to throw a little plus minus out there. So that gives us x equals plus or minus, positive or negative, the square root of 4. The square root of 4 is 2. And then we write out our 2 answers as x equals 2 or x equals negative 2. Always write out your final answers as the positive or the negative, using the word or, not and. If it's and, that means it's both at the same time, which can't be. So it's one or the other. All right. Let's look at problem 5. Problem 5 is more interesting and fun. So it's x squared plus 10 equals 1. So here you're like, yeah, Mr. Race, is a simple one. It's x squared plus 10. We gotta get rid of that plus 10. How do we get rid of the plus 10? You're right, minus 10. So we go minus 10, sorry, we subtract 10 on each side to undo that plus 10. So that gives me x squared equals negative 9. Now what we would want to do here is we would want to square root that, right? To make that just an x. So we go square root. So now I have x would be whatever plus or minus, my bad, the square root of negative 9 is. But we've got all positives here. We got to think about this. Squaring something, it means multiplying it by itself. So I know 3 times 3, or 3 squared is 9, right? What if I had negative 3? Like a positive times positive is positive. What about negative 3 squared? Well, that's negative 3 times negative 3. That's also positive 9. So we would think, like, is there any number I can multiply by itself and get a negative? Well, right now in Algebra 1, we've got positives, right? But a positive times positive is a positive. We got negatives. Negative times a negative is still a positive. Like 0 times 0 is just 0. So just dealing with the regular real numbers, there is no actual value that I can multiply by itself and get a negative answer. So in this case, what we do, anytime we're square rooting a negative, and this is important, anytime in Algebra 1 that we're square rooting a negative, what we're going to say, our answer is going to be, I'm going to write this in a different color so you see it, is no real solutions. We use that word real because right now we're talking about the real number system, as in, well, the real numbers, the ones that you're comfortable with, you know, that you're familiar with. There's things called imaginary numbers, which make up the set of complex numbers that you'll learn about in Algebra 2. Basically, with that, we introduce the idea of square rooting negatives, create a whole new number line, number system, and go from there. And it's actually really, really applicable for things like electromagnetism, light waves, that sort of thing, like things that travel in waves, and, well, other things, like how your cell phone operates. Okay, moving on. But in Algebra 1, if you get x squared equals a negative number, you square root, you have a square root of a negative, your answer is no real solutions, because there's no real number times itself that gives you a negative. All right, problem 6. Let's go ahead and do problem 6. So here we have 2x squared plus 9 equals 9. So we go about this. This is similar to problem 4. Like, what's happening to the x squared? It's getting multiplied by 2. We're adding 9. We got to undo it starting with the last thing. The last thing is at plus 9. So we go minus 9. Minus 9 minus 9. We get 2x squared equals, well, 9 minus 9 is 0. So I got to get rid of the 2. How do we get rid of the 2? Well, it's 2 times x squared. So remember, if it's right next to it, right, it's implied multiplication. Divide by 2. 0 divided by 2 is 0. X squared equals 0. Well, I got to get rid of that squared. We would square root it, plus or minus. But what's the square root of 0? Well, if I continue up, if I have 0, what's 0 times 0? 0, so that means 0 squared is 0, and then the square root of 0 would be 0. Is there a positive or negative 0? No, it's just 0. So here, we just get one answer. We just get x equals 0. So there's the possibility of one solution, 2 solutions, or no real solutions. All right, so now you have problems 1 through 6 in your notes. What I want you to do is I want you to do problems 7 through 12 using these as examples, right? These will help you with problems 7 through 12. So go ahead and pause the video. Remember the time that we're at right now. Do 7 through 12, and now I'm going to talk about problems 13 through 17, and then 18, 19, 20 will be for you to do on your own. All right, so let me erase this now. I'm going to keep this up. There we go. go. Intermission. Hopefully you finished your problems. If you're still watching and haven't done those problems, go ahead and do problem 7 through 12. If I knew how to YouTube, I'd actually like splice in some fun music or something, but I don't know how to do that. So you just have to listen to my ramblings. Although there is that little like cursor at the bottom that you can drag and, you know, skip me erasing the board if you want. All right, let's talk about problem 13. Well, let's dry this off a little bit. So, sorry, this next learning target is still solving, but here we're going to be simplifying square roots while solving. So looking at problem 13, we have 4x squared equals 25. So it's just like the last set of problems, right? We want to solve for x squared, solve for x. But first we got to get x squared by itself. In order to do this, we're going to divide by 4 on each side. To undo that, multiply by 4. Here, though, 4 does not go into 25 evenly, as in the answer is not a whole number. So we're just going to write x squared equals this fraction, 25 over 4. And before you freak out, it's okay. It's just a number divided by another number written in fraction form. Like, it's okay. Like, we got this, all right? Just hold with me. So now we got to square root it because it's x squared. We want regular x. And the undo of squaring is square rooting. So we're going to undo that by going square root. And I'm going to square root the whole thing. And I got to remember the plus or minus because it could be positive or negative, right? Something times something. Sorry, positive times positive is positive. Negative times negative is positive. Now here, this is the tricky thing. This is the simplified part. Whoops. We have the square root of the numerator, right, of a fraction, sorry. This is equal to, so anytime we have square root of something over something, it's equal to the square root of the top divided by the square root of the bottom. So the square root of a fraction is the same as the square root of the numerator divided by the square root of the denominator. So now, hey, look, I didn't know what the square root of 25 fourths was, but I know the square root of 25 is 5, because 5 times 5 is 25. And I know the square root of 4 is 2. So here, my answer, and we still have that plus minus, is plus or minus 5 over 2, because the square root of 25 is 5. The square root of 4 is 2. So our final answer is x equals 5 over 2, or x equals negative 5 over 2. Boom. Cool. So if you have a fraction in your answer, you just, square root the top, square root the bottom, write out your answer as a fraction with plus minus, 2 answers. All right, so let's do another example of this. Try problem 14 real quick, hit pause, try it. I'm going to put it up here. So, problem 14. We've got 49x squared equals 16. Just like this one, here it's a number times x squared equals number. We want to get the x squared by itself. We're going to divide by the 49. So we divide by 49 on each side. 49 doesn't go into 16 a nice number of times, so we just leave it as a fraction. Like, all right, fine. X squared equals 16 over 49. We need to get rid of the squared part on the x. So instead of x squared, we want x. In order to undo the squared part, we're going to square root it. And we remember anytime we square root, we use a plus or minus, because it's going to be positive or negative as our answer. And then we have this square root of a fraction. So that's equal to the square root of the numerator divided by the square root of the denominator. Or the square root of the top over the square root of the bottom. So here I look at this. Hey, I know what square root of 16 is. It's 4, because 4 times 4 is 16. So I get plus or minus 4 over, and then square root of 49, that's 7, because 7 times 7 is 49. So plus or minus 7 over 4. And we're going to leave it as a fraction. So our final answer is going to be x equals 4 over 7, or x equals negative 4 over 7. Cool. So, this part of the learning target, anytime you have a square root of a fraction that's equal to the square root of the numerator, or the top, divided by the square root of the denominator, or the bottom. So you use square root top, square root bottom, write your answer as a fraction, plus or minus, separate those into the two parts. All right, I'm going to erase these. I'm going to do problems 15, 16, 17. And that's going to be your job to do 18, 19, and 20. So here we go. Erasing these. So problems 15, 16, 17 are they're a different type of simplifying that we're going to do here. And they're a little bit more complicated as well. All right, so problem 15 is just x squared equals 75. So it looks pretty simple, right? We're like, oh, it's x squared equals 75, and you get rid of the square. I'll square root both sides. So I go square root, that gives me plus or minus square root of 75. So here, x equals positive or negative square root of 75. But there's not a nice number that number times itself equals 75. Like we look here, we're like, well, 8 times 8 is 64, 9 times 9 is 81. Emma, sorry. Hey, Emma, what you barking at? I don't even know where she is. Oh, there she is. Mean mugging me from the couch. I see you, Emma. Yeah, I see you. Sorry. So, 8 times 8 is 64, 9 times 9 is 81. What number times itself is 75? It's not a nice number. It's not like a nice whole number. So what we got to do is we got to simplify it. We look at this 25. There's two ways to go about this. And I'm going to show you them both. What we do is we just say like, all right, 75 is what times what? Because if we have the square root of something times, well, we'll get there. So here, I say 75 is the same as 25 times 3, right? You with me? So that means that we can just say this is the square root of 25 times the square root of 3. Emma. Sorry. So square root of 25 times the square root of 3. But what's the square root of 25? It's 5. So here it's 5 times the square root of 3. So what we're using here is we're using basically an exponent rule that says the square root of 25 times 3 is the same as if I take the product of those square roots, if the multiplication's outside the square root. So here, instead of having plus or minus square root of 75, it's plus or minus positive negative 5 square roots of 3. So our answer here is going to be x equals 5 square roots of 3, or x equals negative 5 square roots of 3. Okay, so what I did there is I looked at the 75 and I said, do any of these numbers, 1, 4, 9, 16, 25, 36, blah, 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 do any of those divide into 75? Or is any of this times another number going to give me 75? And I know, right, 75 cents is 3/4, right? So 3 times 25 is 75. So that's where that 25 and 3 came from. And I wanted the 25 because the square root of 25 is 5. Okay, let's do a couple more problems. So problem 16 here, we have x squared equals 12. So once again, we're going to square root both sides. So square root plus or minus square root. So here I have x equals, because the square root gets rid of the square, plus or minus square root of 12. Now, 12 is between 9 and 16, so square root of 12 is going to be somewhere between 3 and 4, but once again, it's not like this nice number that we can just find. So another method I can do, instead of saying which of these divide into 12, which you can probably see which of those divide into 12, right, is we can do what's called like a little factor tree. So I say, hey, 12 is equal to 6 times 2, right? 6 times 6 is equal to 3 times 2. And now here, I see that I've got this 2 and this 2, right? Which means 12 equals 3 times 2 times 2. If you break a number down into its factors, anytime you see two of them written together, like 2 times 2, that's a perfect square. So this, 2 times 2 is 4. 4 is a perfect square. So basically, I can just say, well, this is the same as the square root of 4 times 3. I can break that into the square root of 4 times the square root of 3. And I know the square root of 4 is 2. So I can rewrite it as plus or minus 2 square roots of 3. And then the answers are x equals 2 square roots of 3, or x equals negative 2 square roots of 3. Sorry for the squeakiness. Yikes, Jiminy. Oh my goodness. Okay, I won't use this pen anymore. Sorry about that. So, x equals 2 square roots of 3, or x equals negative 2 square roots of 3. So kind of our goal here when we're simplifying these square roots is we're trying to get the smallest number that we can inside the square root. So basically what we're doing is we're taking this number that's not a perfect square, it's not one of these, and we're saying, hey, is this divisible by any of these other numbers? In this case, 12 was divisible by 4, which is a perfect square. So we basically like factor that apart and then take the square root of that number. 75, it was 25, right? 75 was divisible by 25. So we pulled that apart. Square root of 25 was 5. All right, one more problem. Then you'll be ready. Well, you should be ready to do the next ones, 18, 19, and 20. So here we got problem 17, which is x squared equals 45. I want you to go ahead and give this one a try. Try it, pause it, try it, and then I'm going to show you the answer. So go, pause. Intermission, right now. All right, intermission's over. Hopefully you paused it and tried it, and now we're going again. So here it's x squared, so we're going to square root. Square root both sides, you get a plus or minus, because anytime we're square rooting an equation, you got to go positive or negative. So here I have x, because the square root of x squared is x, equals plus or minus square root of 45. So I look at that 45, and I say, do any of these numbers on this side divide into 45? 1, no. 4, no. 9, yes. 45 is 9 times 5, or 5 times 9, either way. I'm like, cool, well that gives me plus or minus the square root of 9 times the square root of 5. We know the square root of 9 is 3, so here this gives me plus or minus 3 square roots of 5. So my answer is 3 square root of 5, or negative 3 square roots of 5. All right, those are our final answers. So work on problems 18, 19, and 20. Use problems 13 through 17 as your notes for those. And if you got questions, or if you have any questions, you can email me, you can go to my office, or you can log into my office hours, which I'm emailing you when office hours are, and like the code to the Google Meets thing. You can also just use Google to help you out too, okay? So, good luck. Hope you enjoyed the video.